Okay, now let's look at some real examples of Monte Carlo simulation. So we're going to skip the inventory model for a little bit because that's a little more involved when we set it up in Excel. So let's look at a simpler example first and then we'll come to the inventory model. Okay, so this is a queuing problem and it is Port of New Orleans. So fully loaded barges arrive at night for unloading, and the number of barges coming each night varies anywhere between 0 and 5. Okay. The supervisor has information which can be used to create a probability distribution for the daily unloading. Okay, so barges are unloaded first in, first out. The barges must wait for unloading, which is expensive. So you want to make sure that we have enough staff to be able to do this, and we want to simulate and see what is the pattern. Right now, 0 to 5 barges arrive every night, and we have probability distribution like this for number of arrivals, and then unloading rate, again from past experience, and we have a probability distribution for that. So we match the unloading rate and barge arrival and see at the current rate what is it going to look like in terms of how much time the barges are spending waiting to unload. So if we increase the daily unloading rate, will we be able to reduce that time by significantly or not? And how much can we reduce the time of waiting and so on? Okay, so let's set up the model in Excel. So here we have overnight arrivals. So this is not demand, it's arrivals. Okay, now 0 through 5. Okay, and the probabilities are given. So I'm getting the probabilities from here from the textbook. Okay, so well we have to set up the cumulative probability. All right, sum of that to that, C9 to C9, except that the first C9, if you make that into an absolute value, then and then if you copy, you'll get cumulative probability. Okay. So now we're going to set up the arrivals, okay, and the lower limit for VLOOKUP. So arrivals there, right? Now the VLOOKUP lower limit, remember, is 0 for the first one, and then it is the cumulative probability of the previous one. Okay, so that would be, so we don't have to, when you do it between 0 and 1, you use RAND functions. We really don't have to worry about whether this lower limit goes with that or with the other one. So because that's probability of that is 0. It's a continuous probability. So now with this, we'll be able to simulate the arrivals, right? So we have day 1, okay, day 1 through 15. So we want to simulate for 15 days. Okay, 15 days. Okay, so overnight arrivals can now be simulated using VLOOKUP. Okay, so that'll be VLOOKUP. Okay, so of course we have to generate the probability, which is the RAND function. So RAND will generate a value between 0 and 1. And now you look up that table and you have to make that absolute reference. So this can be copied and then comma 2 for the arrival should come from column 2. Okay, so that gives us how many arrivals in a given day. Copy that and you have the arrivals simulated for the 15 days. Okay. All right. Now, total waiting to unload, let's get to that in just a second. Okay, unloaded for the day. Okay. So we have to be careful here. Unloaded for the day, unloading rate. Um, we have the daily unloading rate 1 through 5, right? And the probabilities are given. Okay. So once again, compute you compute the cumulative probability and make sure the first C19 is absolute referenced. Okay. And then the unloaded rate, so that's our lookup table. So from there, so 1 and goes up to that. And the lower limit, first one is 0 and the second one is the cumulative probability from the previous row. And now that will be our lookup table for unloading rate. So again, we can use a V lookup, and once again you start with rand. All right, and that is our lookup table, and press F4 to make it absolute reference so it can be copied. And the second column gives us the unloading rate. Okay, now of course you can copy that, but before that let's pause for a second and see what happens. Okay, now the arrivals is 1, but unloading we are saying is 2. How is that possible? Can unload more than what is there. So this is how many barges can be unloaded. So we really need to make sure that this doesn't exceed the total barges available to unload. So for a very first day, what is available to unload is just what the overall overnight arrival is. Okay, that's just 1, right? So you can unload the minimum of what can be unloaded, right, comma, the actual number of barges waiting to unload. So only the smaller of the two, okay, can be unloaded. All right. So then waiting at the end of the day is total waiting to unload for the day minus what we actually unloaded. So that will be 0. Since we used min here, this number can never be greater than that. So you don't have to worry about using if function or anything like that there. Okay. Now waiting at the end of the day, day 1. So now total waiting to unload for day 2 is the total waiting to unload from the previous night plus new arrivals, or previous day plus the new arrivals overnight. Okay, so now this can be copied like that, and now that can be copied. All right, so now we have simulated 15 days worth of operation. Okay, now we can find the average arrival rate. Okay. On the average, how many barges arrive per day? Then we can copy that to these two. So how many barges are we unloading on the average? And on the average, how many barges are waiting to unload at the end of the day? So still waiting. We have not finished unloading. Okay. Now this is a model for one 15-day operation, and in Monte Carlo simulation, what we want to do is to replicate this again and again and again for X number of replications. So you want to replicate these 15-day operations, say 100 times, 500 times, or 1,000 times, and then collect statistics. Okay, so which is what we will do next.